Welcome back to the unit on fractions and decimals. Today's lesson is about calculating distance and area with fractions, with fractional side lengths. So you will use division and multiplication to solve problems involving fractional lengths and involving area. So here we have a cyclist who planned to ride 9.5 miles, but only travelled 3 7/8 miles. What fraction of his trip did he travel? So the first thing I want to do is estimate what my answer will be. So he wanted to travel about 9 miles and he travelled less than 4 miles. So half of 9 is 4.5. So he travelled less than half of his distance that he wanted to travel. So less than half. Just to give me a ballpark figure, so when I get my answer, I'll have an idea if it's reasonable. So he travelled 3 7/8 miles out of 9.5 miles. So I want to divide 3 7/8 by 9.5, and to do that I need to have them both as improper fractions. So 3 times 8 is 24, and 24 plus 7 is 31. So 31/8 divided by 9 1/2. So 9 times 2 is 18 and 1 is 19 halves. And we've learned that dividing by a fraction is the same as multiplying by its reciprocal. So 31 over 8 divided by 19 over 2 is the same as 31 over 8 times 2 over 19. And so now we can multiply these and find our answer. I am going to do some simplifying. So I'm going to divide 2 and 8 above and below the line by the same factor, and the greatest common factor is 2. So 2 divided by 2 is 1, and 8 divided by 2 is 4. And now I can multiply easier numbers. 31 times 1 is 31, and 4 times 19 is 76. And I did that by saying 4 times 20 is 80, and minus 4, because 19 is 1 less than 20. 4 times 1 is 4, 76. So 31 over 76 is the fraction of his planned trip that he travelled. We can represent the area of a rectangle with an area model. So here we're calculating the area of a rectangle measuring 2 1/4 inches by 4 3/4 inches. So I've drawn the area model already. So 2 inches and 1/4 of an inch and 4 3/4. And I can calculate all of these areas then. So 4 times 2 is 8. 2 times 3/4 is 6/4. 4 times 1/4 is 4/4. And 3/4 times 1/4 in the bottom right hand corner here is 3/16. And if I add all of these together, this is my partial products model here, I will have 8 plus 4/4 plus 6/4 plus 3/16. So that's 8 plus 4/4 is 1. 6/4 is 1.5, and 3/16. 8, 9, 10.5 plus 3/16. And I want to add my half and 16ths together, so I need a common denominator. So I'm going to say 10, and if I want to make the half into a fraction with 16ths, that would be 8/16. And I still have the 3/16 here, so it's going to be 10 and 11 16ths would be the area of the rectangle using the area model. And if we have an area problem like we have here, where a tray has a length of 11 1/4 inches and an area of 50 5/8, altogether the whole thing, I know that and we want to find the width. So the area of a rectangle is length times width. So the area is 50 5/8, and that is 11 1/4 times the width. So if we divide both by 11 1/4, we'll find the width. That's my plan. So I'm going to say 50 5/8 divided by 11 1/4 is the width. And I need to convert these into improper fractions. So 405 eighths, 8/50 is 400. 400 plus 5 is 405, divided by 11 times 4 is 44, and 1, so 45 fourths. And that's the same, or to calculate this I can multiply by the reciprocal. And I can cross multiply again here, or cross divide. 4 divided by 4 is 1, 8 divided by 4 is 2. And so I'll get 405 over 45, and I can divide both of these by 5. 9, 5, 8. 9, or 81 over 9, because I divided both by 5. And I can further simplify by dividing 81 by 9 and getting 3. So the width of the tray is 3 inches. So to summarize, we multiply the side lengths of a rectangle to find the area. And if we know the area and one side length, we can find the other side length by dividing the area by the side length that we do know. So today we used multiplication and division to solve problems with fractions and to find area and to find side lengths. And that's the end of today's lesson.